Il prossimo intervento verrà tenuto in lingua inglese, quindi in cuffia sentirete lo speaker parlare in inglese. Se volete sentire la traduzione in automatico dovete usare l'applicazione su wmf.ibrida.io. In quel caso vi tocca usare il telefono o gli auricolari o vi tenete il telefono vicino all'orecchio. Tenete conto che è una traduzione molto AI, non così AI. Better if you use also the headphones so you can hear the volume of the...
Okay.
Okay. Okay.
Hey.
So we are ready for the next speaker on stage. It will be Jeff Andrade. He is a staff engineer at RPC. He will talk about moving from raw data to enriched data. Sorry. You will have a stage for the next 40 minutes.
Yeah.
Okay.
Okay.
I'm here, and I remember to everyone this is a silent room, but we will really like when you end the speech with a round of applause. It's very, very pleasant for us. Okay.
Thank you. Okay. So, first of all, thank you all for being here. It's a pleasure. I'm Jeff. I work for RPC. It's a company which is a joint venture from BMW. Okay, thank you. It's a joint venture from BMW. And we have several projects. We are now stepping more and more into AI. And we work on several different areas. I'm the staff engineer for data and technology. But yeah, we have training, people empowerment, and digital transformation, and much more, of course. Sales, we are specialized as well. And yeah. Those are some of our customers. We have strong expertise in automotive area, so but not only, of course. And yeah, we have some certifications, and this is me. I've been developing software for the last 14 years now, I guess. And I've been stepping into open sourcing a lot recently. I've been contributing to browser use. I don't know if you are familiar with that, but browser use is probably the most known automatic browsing agent, autonomous browsing agent we have now. It's the base for example, Manus AI and many other frameworks and environments and platforms. So this is what we're going to briefly talk today about AI agents and frameworks and scraping data and so on. And how can we use this data? What can we do with it? And how is the current state of data extraction and and intelligence? So I think at this point, most of you may know about what are LLMs. So they are large language models based on this transform algorithm, and they have huge data sets for. Um, so we have large because we have billions of parameters on those models, and yeah, it's basically what they've learned so far. And yeah, so how they work, they predict what is uh, the next word or token that has the highest probability to appear on a given context, on a sentence, based on a sentence. So it's basically text generation based on scoring on the statistics. And yeah, so AI agents, what they are. Uh, they are software. They have the LLM as a brain, and the difference is that an agent can achieve goals. You can give some goal, and the agent can reason over it and use tools, use plan the steps to achieve these goals until it accomplishes it. And it's just not a chatbot. Instead of just asking and getting an answer, the agent is capable of building a plan and and achieve this goal. And you can use multiple stuff as tools. You can give this agent APIs. You can give it functions, whatever. You can integrate it with something. Uh, and yeah, for example, in this case, we will be talking about giving it a web browser as a tool and actions you can perform with a web browser. So uh, why do we need it? Because in multiple times we will have dynamic content, dynamic websites that you need human interaction to go over it, to perform actions. And in this case, you can use the agent to act as a human, to click somewhere, to input some text, to navigate to the web page, and perform actions that only a human will be able to do. Um, yeah. So, what are the current players on this market? What are the current frameworks and types we have? So, for frameworks, we have LangChain. It's a framework. I think it's available for Node as well, but mostly I use it for Python. And yeah, you can use tools with it. You can do reasoning. You can plan. You can it's broadly used because it's open source as well. Recently, I've added. There is a library called LangChain Community, and I've implemented, I guess, 99% of the playwright tools for it. So right now you can use it and perform autonomous navigation using a LangChain. It will, if you install the LangChain Community library, you can open a web page, ask it to click somewhere, to navigate, to search for something, and it will be able to autonomously navigate, Google something, extract data autonomously, save this data to a JSON file, to CSV, whatever. We have browser use, which is the current big player I told earlier. So it uses Playwright as well under the hood, and it's a junction of LangChain and Playwright, basically. So it's the most well-known um, framework so far, I guess. And yeah, you can build your agent and pass a prompt for it, and it will autonomously open Chromium and start browsing. You can resume existing sessions on Playwright as well, which is one of the most recent features we've added to it. You can just create your script, your playwright script, and at some point you need some reasoning. You can just give the session, the current session to the current playwright session to browser use, and it will just resume that session, do the reasoning you need for that specific point, and go back to your script. You can use multiple web browsers. You can customize it as much as you want. Recently, Google launched as well. Google AD Key is the framework. It's also one of the key features they have. It's that it has multi-agent. So you can have multiple agents at once in a single script. You can create multiple agents, and they can interact and pass information to each other. So it's pretty good. It's I think it's fairly on an early stage, so there's a lot of work to do, but it's promising, and it has as well a UI that comes out of the box, so it's pretty amazing. And most recently, we have different agents from AWS, and I think the key feature for that is that it is really easy to use. It's not complex. Instead of creating long and complex workflows, it tries to simplify everything. So it's pretty cool to use, and it's yeah, of course it's as Google ADK. It works really well with AWS environment, and the same for Google. You can it simplifies the usage on Google Cloud Platform as well. So we also have the no-code and low-code platforms. We have Manus, as I said, which uses the browser use framework under the hood. We have N8N, which is for orchestration and so on. You can self-host it. It is open source as well. You can self-host it or use their cloud product. And we have Evo AI, which is multi-agent as well, and it has this agent-to-agent communication as well. So it's pretty cool. You can design and create AI agents with different roles, and they can communicate with each other. So it's pretty amazing. So what is the basic structure of a LangGraph agent? LangGraph agents are the new agent library from LangChain. It's more modern. And we have the LLM, which is the brain, the thinker. We have memory and state. So you have memory, you can store long-lasting or persistent memory to the agent. So it will remember the steps the agent has done earlier and keep the state. Usually you have the state that will tell what is the current status of your agent. So you can tell which step is this agent in. You can put custom information, custom metadata into your agent and store it in the state. So it's whatever you need for keeping track of this agent. What is it doing right now? What is the current status of this agent? So it will be on the state. We have the tools, of course, as any agent. So it can perform calculation. You could Google something. As I said, you could call APIs. This library from LangChain community, you can, for example, perform automatically the post requests, get requests, whatever. There are multiple tools available this agent can use. You have Scratchpad, which is like like a whiteboard for the agent, because when it's planning, when it's performing some reasoning, it's thinking over something, it creates some temporary data. It will start thinking of what this agent is going to do. So it has this temporary memory to do the reasoning, and so it's called the scratch pad. It's part of the prompting. So uh, and we have the prompt, of course. The prompt involves the system messages, which are the definitions for example, this agent's role. What is the purpose of this agent? Yeah, and the human message as well. What is the query? What is the user request? Uh, yeah. So with this, we can have agents as web scrapers. So we are going to extract data from the internet using the AI agents for that, and using the tools as I told earlier. Um, so we have the current state of internet is that it's not static anymore. So the web pages are all dynamic. We have frameworks such as React, Vue.js, Angular, and they generate the web pages are generated on top of languages dynamically with JavaScript. So usually when you open a web page, just a part of it it's pre-rendered, so you cannot uh, you cannot tell what content will be there, and it makes pretty tough for scraping data to navigate through the websites with a script that is not dynamic. You have to adjust your script when the website updates. So this is the pain point right now of extracting data. You have usually when you work with data extraction, you have a huge backlog of maintenance because those websites they update. We track, for example, more than 100 websites. You can imagine that for a single brand, we extract data. We have a different web page for each country, for each language sometimes. So we have hundreds of websites to track, and they are constantly being updated. Um, so we can sum up agents with Playwright and cut off this static part of the script and have something that is more dynamic. Uh, it can click on something, scroll the web page, look for something else, and grab the data, of course. And so we have two ways of get data from those websites. We have structured and unstructured data. So structured data is when we have like a JSON file, a YAML file, a CSV file, something that we have a fixed structure, and we can just tell, okay, this is a price. For example, you have a float, for example, and you can work with those numbers. You can sum them, but sometimes you have, most of the times, I would say, you have unstructured data, which is the text content from the website, or a content from PDF files. So you cannot tell what exactly is that data. So you cannot tell if it's a number or just some text. And when do we need AI? We need it for dynamic classes identifiers. As I said, we have many frameworks right now, and front-end these days are basically those frameworks. We have, of course, server-side rendered web pages, but most of the internet now is based on React and Vue.js and Angular. So most of it is dynamic, and you will face elements like this, and you cannot tell because every time you load it, it will be a different class. So you cannot tell what is this just from this definition, from this class. It has no fixed ID. It has I don't know, maybe a data class that will help to identify it because it's just dynamic. We have elements with no identifiers, so it's also pretty difficult to um, identify it on a static script. For example, if you have a button like this in the middle of a web page, the only way you can, I don't know, if you have more 3 buttons, the only way to tell which button you need to click is based on the position. So you can have on your script, okay, click on the 4th button on this page. But then the page can be updated and your script will not work anymore. So it's pretty hard to identify this, and it generates hundreds of maintenance cases. Yeah, you have conditional elements as well. They will be only visible based on a condition, so it's also pretty hard to work with them because they will simply not exist on the web page as you load it. We have shadow DOM elements. So as well, they don't exist until you perform some action. So it's pretty difficult to work with them just by a static script, Playwright script or Selenium script, whatever. We have the dynamic keys. For lists, for example, you have keys that cannot be repeated because it's a list. So the keys can be dynamic. So okay, you can work with positions, but the list can be, and usually it is dynamically rendered. So you can hardly tell what is going to be there until the content is fully loaded, until you have interacted with it. We have as well inputs with custom rendering, which is when you have a input, some I don't know, some text input, but or in this case a dropdown, which is a better example, which it's an element that acts as a select, but is not a select. It is just a div with a list inside of it, but it works as a select. So it's also difficult because internet these days have a lot of those. And we have another annoying example, components with multiple identical elements, which also makes difficult to put this on a script and make it work. So our agent has what we call nodes. We have the planner node in this case, I'm going to show you, and it will basically break down the user prompt. Then it will formulate a sequence of actions to achieve that goal, and then it will provide to the next node, which is the navigator node. So this agent has 2 nodes, the planner and the navigator. For the navigator node, we will extract the DOM tree, so it will load all the existing elements on the page. Then it will select the right tools to interact with them. So you can have a 1 tool per element, for example. If you have a button, you need a tool that will click on it. And finally, execute the actions. And this is called a dynamic prompt chain because you have the initial prompt, then you have the assistant, and you have an input, then it will do the planning, it will navigate, then it will pass from the planner node to the navigation node, and then it will say this goal, this task is concluded. The planner node generated some steps, right? So it will say that the step is concluded and give it back to the assistant, and it will call the follow-up prompt. Because, okay, let's say you need to navigate to a car brand's website, and you need to, I don't know, you want to find out the leasing options or financing options for this car. So you have multiple steps to do that, and this prompt is chained. So you will you prompt the agent to go to that website and find out the financing options. So first it will break it into tasks, which is of course opening the web page first, then clicking on some model or a list of models, then click on a car, then find a button or an element for choosing the financing options, and then even picking the amount of the term on months. I don't know, the mileage you might choose if it's a leasing, for example. And this is breakdown into a chain of prompts. So everything is a prompt. Every part of this is a prompt, and it will automatically call the next roll of prompting, the next round. So it will go back to the assistant and call the next step. So we have the user prompt. We have it goes to the planner node. It calls the navigator node then, and it calls the tools. So first it will navigate to a URL, extract the DOM, and choose whatever tool it may require for achieving the goal, for completing the task. So it could be clicking on an element, extracting some text, or even navigating back. If it finds out that it's the wrong page, it happens. Sometimes the agent expects something to have to go to some path, some way, and it's wrong, so it goes back automatically. And it will do that over and over again until the goal is achieved, until it considers the whole prompting, the whole task done. Yeah. So first I will show you how browser use works, as I've been part of the development as well, and it's pretty cool. So this is some basic code. We have some models there. This will just navigate to Yahoo Finance and find the 5 best stock options, and get the data like price, volume, change in percentage, and give the reason why is that a good option for buying. So it will load the website. It will find out automatically that it needs to accept the cookies. Okay, then the web page is rendered. It will then identify whatever you can interact with and highlight it with different colors and give indexes to it. As you can see, this is the index 15, 16, 17, and this is used as a parameter for the clicking tool. Click on the element with the index 18 or whatever, or 16. Yeah. Afterwards, it will scroll down, look again at what it can interact, extract the text, and here we have all the data as we asked it during the prompting. So you can see that the agent considered it a success, and the reasons as well. That part is the reasoning or the intelligence part that is cool from using AI agents for this, or using AI, because you can use it for analyzing data and not just performing actions. I've asked for this agent to give me reasons why it's a good option. So the agent is capable of that. And we have LangChain. This is the one I rewrote 90% of it, and it's also capable of navigating autonomously and doing basically the same thing. In this case, I asked it to go to Volkswagen, Italy, and get for me the data, the monthly fee for each model, for each car, and it should do. So here is the DOM tree. So we have all the elements here from the web page. It's the first action it performs. We can see here that it called the tool get elements. So it's very explicit. So you can see what is it doing. Get elements. So we found a selector main. So it said that I'm unable to find the car prices and conditions on this page. So it won't fail. It will try a different approach. So that's what a human would do, right? So it extracted the whole text automatically and found a selector that might be more suited for this and called the tool again, get elements. And now it found at least the DOM and found a grid items element as well. And now called the extract text from it. It called the extract DOM tree again from that element. So it went deeper and deeper into the elements until it found the list of cars. It still has trouble to find it, but that's the dynamic chaining of actions. So it failed and it called again, okay, this didn't work, so we have to find another approach. You can configure as well how many times it should fail, because you can have an endless loop on this, right? And again, now it found the data we wanted. So job finished, and we have all the data in a JSON file. But it's still text, as you can see. Everything is wrapped in quotes, and this is not good for working with, because this is just text. But at least the agent is capable of identifying what is what in that model. I gave it a pedantic model, a model telling that I need this tax and this the price as well, and the model name, and it will automatically classify it and assign it into the pedantic model. And now, as I said, everything is text so far, so it's time to transform this data. This is what our agent found so far. So it's the VW, Volkswagen website from Italy, and we have the pricing per month, we have the taxes, we have the months or the term, a initial, a first deposit, and the mileage and everything for all the cars. So we have then raw data, we have then text only, and we need to transform it to data we can work with. So we will use Pydantic in this case for validating this model and transform this data into data that we can compute, data that we can work with. So using Pydantic, we will create a model with a series that is a string. We will give types to each data we have. So we will tell that the series is a string, monthly payment should be an integer, 10 is a float, TAG is a float as well, the duration in months, it's an integer, down payment, balloon payment as well. So, and this is the output we expect. And in this case, we can work with. This case, we can compute, we can calculate what we are going to pay and for how long, the total, whatever we want to do with this data. This is very useful in this market for dynamic pricing. And it's one of the services we provide, we RPC. We work, we have this framework of dynamic pricing. It's, we have several customers, and It's now being used for the automotive sector, but it's not the only application we have, right? So here's the validation logic. We have the monthly payment, down payment, balloon payment. They all can be validated in the same kind of regex to have then the data transformed from string to a number, to an integer or a float we can use for the calculation. And the same for the taxes. We will pass it and extract just the numbers. And yeah. So then the output we have is this well-structured data, which is in a format that we can perform. The machine can work with it, so we can do statistical analysis. We can put it on beautiful dashboards. We can filter search. We can use it for training, for machine learning, which we do right now. We can insert it on a database and we can export it to different formats. So now we have data, we have structured data, we have the output we wanted. So now we can transform this into intelligence. We can use it for product comparison. We do it as well for our customers, for example. We provide them the data to compare the products to the competitors. So the competitors from those customers, they can we have the data we need to be more competitive, right? We can do the real-time price matching, which is the dynamic pricing. So we can compare what our product offers and at which price and set the price to make it more competitive as well. We could use it for overstock clearance. For example, we have a lot of stock stored and you need to get rid of it. So you can as well use it. You can do it for an automatic seasonal adjustment. You can use the demand-based price for demand-based pricing, and yeah. And what is the future and the impact for it? So from now on, what we expect from this, we expect more powerful agents. We expect bigger context windows, because right now it's one of the challenges is when you extract the whole data, the whole content from a website, it's huge. So it's pretty hard to just give it to your LLM and process it, because you have a small window to work with. You have now GPT-4 and Geometry that has a bigger context, but it is still limited, of course. And we expect it as well to be more multimodal. Okay, we expect as well to have to be more reliable. We expect it you can trust more and more based on the accuracy of your LLMs and have less hallucinations. As I said, you could easily step into an endless loop while navigating through web pages. So we expect less hallucinations. We expect more higher adoption. There is this numbers from Salesforce that says that around 82% of the companies should have AI agents working for them up to 2027. So either by having co-pilots or CRM tools, BI tools with agents, AI agents. And we expect more and more data-driven decisions. Sorry. As I said, we extract data. We have data now. We have structured data, so we can make decisions based on real data and not just on guessing on something or feeling the market. You can see it, and you have like a lot of hands to work with it. Not just you don't need a huge amount of people, looking at the data, reading everything, because you have tools now to do the analysis over it in a matter of seconds on huge data. And we have multi-agents. This is happening already, which is the agentic ecosystem, that you have different agents with different roles, and they communicate with each other, and they work as a company. You can have different agents providing data, providing insights, or performing their tasks as they are more suited to. For example, you can have a model, a LLM model that will perform better for customer support, and another one will handle better numbers. So you have different agents with specific roles, and they communicate, they coexist in the same environment. They will all work together as people will do. And that's it. I hope you enjoyed it. If you have any questions, feel free to reach out. And thank you all for being here today. Thank you.
Thank you, Jeff. Now we have the idea why around 70% of the traffic on the internet is made on agent. It's so easy. Easy? Is it? Is easy? Easier now? After the speech? Yeah. There are a question? Any question? Yeah? One? So keep your microphone. Go.
Thank you for your presentation. Which is the agent you used in this presentation right now, in this example?
The last one?
Yes, no, last one. In the example, you clicked on the background black. No, you used an agent with the different cars, no, Volkswagen.
Yeah, that one is LangChain.
LangChain, okay.
Yeah, LangChain is the framework. This tool set is actually the one I've provided recently to a library called LangChain Community. So you can just pip install LangChain Community,
okay,
and you have access to those tools.
Do you have agency which provide services about create agents? So companies.
Yeah.
Okay.
We do it.
We can contact you by this contact.
Yeah.
Okay. Thank you.
Please.
Thank you.
Any other question? Yep.
Thank you for the presentation.
Thank
It was very interesting. I have, to be honest, two questions. One is the agent can handle like a basic authentication on websites, and the other is there are something like privacy problems that we have to take into consideration.
Yeah, thank you for your question. And yeah, you can perform authentication. There are multiple ways of doing it. For example, I have cases that I add tools for making post requests and getting tokens and keeping the session based on the web token, adding it to the headers whenever I need to navigate. But you can do the usual way as well. You can open the login page and set the user and password. In this case, we have, yes, security concerns, but there are as well, for example, in Pydantic, you have a secure string, I guess. It's because it's reduced, the name, but there is a tool in the library for omitting the sensitive data. So when you are handling API keys or passwords, for example, you can wrap it in this function, and it will just be asterisks in the logs and what is sent as well to the LLM. So the LLM won't see it. It will see just asterisks. And for this is one of the bugs I've solved as well for browser use, because the logs were login passwords a while ago. So this is one of the bug fixes I did there. So right now it will show asterisks as well. Thank you.
Any other questions? No one who want to know if Langchen can identify traffic lights, bicycles, crossing lines? No? Or
Spoiler alert, it can.
yeah, I know, and it's amazing because many of us have seen the meme where there is what make us human, no? Identifying traffic lights. Okay, now also Agent AI can identify traffic lights.
But
question
curiously, some models will prevent you from doing that. Some models will tell you cannot do that. This is out of bounds.
Given how agents are changing the scraping game, do you think that this will also change the internet? Or I mean, do you think that developers from now on will implement more open APIs to avoid scraping, since it's becoming so easy?
Yeah, totally. As you said, currently we trust that those click on the birds on this image will prevent the navigation in this page. But now, if you have a nasty LLM model, it will do it. It will perform it. It will click on the bird and go further on the page. And it's also capable sometimes of finding things that will be difficult for a human to percept on a web page. So tricks, ways to go. For example, I had a terrible, bad idea a while ago of creating a vulnerability scan web page scanner based on LLM. And I've explicitly told it, please do not destruct anything. And the first thing it did was trying the SQL injection, drop in the users table, and it worked. So, yeah, sometimes it will try the shortcuts and it will work. It's capable sometimes of doing things that we human would not think of, and it works. So it might change a lot the way I think sometimes in the future maybe it will impossible for humans to create scripts that will be strong enough to hold AI, to make it secure, to make a web page secure, especially after that. I've learned the lesson. I've destroyed the script forever. I won't try it again, but yeah, it was pretty scary. Thankfully, the web page was like a dummy page because it was not the one in production, of course, because otherwise I would be maybe in jail today. But yeah, it was pretty scary.
Okay, no jail right now, but Lance. So thank you, everyone. Thank you, Jeff, again.
Thank you.